In this video, we're going to talk about the second type of compound probability, which is a dependent compound probability. Two events are dependent if the outcome of the first event affects or changes the outcome of the second event so that the probability is changed. And this means it's changed for the second event. So I'm going to show you what that means by an example. So this example, the picture above represents a dresser drawer of socks. What is the probability that you will choose a red sock, keep it, and then choose a white sock? Now here's the big thing that's changed about these. This word keep it is a dependent phrase. So we learned about that independent phrases in the previous video. Here are some anything that is synonymous with keep it. So does not put back, or does not replace, those kind of things. So anything that shows that whoever is taking it and does not put it back, they keep it to themselves, then go to pick something else, that is a dependent phrase. And the reason why, and we're gonna work through this problem to show you, it changes the outcome of the second probability. So again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total socks in this drawer. So we treat the first probability like normal. We want to choose a red sock, so there are 2 red socks out of 12. But you picked one of those red socks and you decide, hey, I want to wear this red sock, and you put it on your right foot. That sock is no longer in your drawer to choose from. So that means that there are now only 11 socks in the drawer to choose from. And out of those 11 socks, you have 3 of them that are white. So again, with this, what we do between multiple events, we multiply. So I'm going to simplify this down, and I'm going to change this to 1/6. And I'm going to then, because of the change over here, I can cross simplify. 3 goes into 3 once, it goes into 6 twice. So I'm going to rewrite this. I have 1/2 times 1/11, which is 1/22. Now, one thing that I do want to show you is I'm actually going to change this up just a tiny bit, because with dependent probability, we're going to use the same example, but I want to change this up. I want to know the probability of getting a red sock, keeping it, and then another red sock. So here's where you have to be very, very careful. Remember, dependent probability means you don't replace it. So just like in this first one, we had a red sock was 2/12. You put that red sock on your right foot, and there's no longer that red sock to choose from. The total is now still 11, but there is now, because you put one of those red socks on your feet, you now only have 1 red sock to choose from in that drawer. So do note, the numerator and the denominator were affected in the second probability. So again, this reduces down to 1/6, and it is a 1/66th chance of a red sock keeping it and another red sock. So with this, we're going to talk through one last time. Since the first sock was not replaced, choosing a red sock on the first try has an effect on the probability of choosing a white sock on the second try. This is a dependent event. So if the first event changes the outcome of the second event, that is what results in a dependent compound probability.